Hey y'all, today is February 25th and I'm doing a little mini lesson on lesson 6-2 that we did in class today. So one of the first things we talked about was dot plots, and we actually made a dot plot in our notes, but right now we're just going to focus on interpreting dot plots. So the dot plot shows the number of goals scored by a hockey team in the first 15 games of the season. And then we're asked to find the mean, median, mode, and range of the data. So one of the things I want to remind you is the mean is the average of the data. And the way we find the average is we add up all of the data points and divide by the total number of data points that we have. So when data for me is organized in a dot plot, I add by columns. So my first column is 0. And there's one data point in that column. So I'm going to start with 0. Okay? Now my second column has 3 data points and they're valued at 1. So 1 times 3 is 3. So 0 plus 3. Okay? My third column is my 2 column. And there are 5 data points there. So 5 times 2 is 10. So I'm adding 10. Now my 3 column doesn't have anything, so I'm skipping that. My 4 column has 3 pieces of data. So 4 times 3 is 12. So plus 12. My 5 column has 1 data piece. So 5 times 1 is 5. And my last column, 6, has 2 pieces of data, so 6 times 2 is 12. So I'm going to add all of that up. 0 plus 3 plus 10 plus 12 plus 5 plus 12. And when I put that into my calculator, let's see what I get. 0 plus 3 plus 10 plus 12 plus 5 plus 12. I get 42. So 42 is the sum of all of my data. Okay, now I need to divide that by the number of data points that I have. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So to find my mean or my average, I'm going to take 42 and divide by 15. And 42 divided by 15, I get 2.8. So 2.8 goals is the mean. Okay? So now that we've found the mean, we need to find the median. So I'm going to erase this here. The median, we need to remember, is the middle value of our data. And in order to find the middle value, I need to write my data in order from smallest to biggest. So I'm going to do that over here. So I've got a 0 to start with. Okay, then I've got 3 ones, so 1, 2, 3. I've got 5 2s, so 1, 2, 3, 4, 5. I don't have any 3s, so I'm going to skip that, but I've got 3 4s. 1, 2, 3. I have 1 5, and I have 2 6s, 6 and 6. And I just want to double check and make sure that that's 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That just verifies that I didn't skip any, right? So now in order to find the median, I'm trying to find the middle number in my data. So I'm going to cross off the smallest and the biggest, and I'm going to work my way in towards the middle. So I'm crossing off 0 and 6, 1 and 6, 1 and 5, 1 and 4, 2 and 4, 2 and 4, 2 and 2, and this number right here, that is my median. So that is the middle number in my data set. So my median is 2 goals. Okay, now the mode. The mode is the number that occurs most often. Okay, so the mode occurs most often, and I can easily see it in my dot plot. 2 has more data than any other column. There are 5 data points there. So 2 is my mode. And finally, the range. Now, the range is the difference between the biggest number and the smallest number. So to find it, we take our maximum value and we subtract from that our minimum value, right? So our maximum value in this dot plot is 6 and our minimum value is 0. So 6 minus 0 is 6. So our range is 6. Okay? So now that we've talked about dot plots, let's talk about box and whisker plots. So the box and whisker plot shows the weight of players on a football team. Identify important parts of the box and whisker plot. So A, label the 5-number summary on the box and whisker plot. So the 5-number summary is what we use to make a box and whisker plot. So we always start with our minimum value. So this very first point is our minimum, or the smallest value. Now the second point is our lower quartile, which is also called Q1. It is the median of the lower half of the data. Now the line that divides the box into 2 sections is the median. It is the middle value of the whole data set. And the back edge of the box is our upper quartile, or Q3. It is the median of the upper half of the data. And then finally, our last dot back here is our maximum value, or our biggest value in the data set. Okay, so those are the 5 numbers that make a box and whisker plot. Okay, now we've labeled the 5-number summary on our box and whisker plot. B, what is the median weight? Well, I look at my median right here, 300 pounds. So the median weight is 300 lbs, or 300 pounds. Okay? What percent of players weigh between 240 and 300 pounds? Well, we need to recognize for this question here that a box and whisker plot divides the data into 4 sections. And when I look at it, here's section 1, here's section 2, here's section 2, here's section 3, and here's section 4. And each section represents 25% of the data. You need to know that. Each section represents 25% of the data. Okay, so I'm going to get rid of those labels there. So what percent of the players weigh between 240 and 300 pounds? Well, 240 and 300 pounds is right there, right? So that's just one section. That is this section right here. So if each section is 25% of the data, what percent is that half of the box? 25%. So 25% of the players weigh between 240 and 300 pounds. Okay. Now the last question, D. What percent of players weigh no more than 320 pounds? So we need to recognize no more than 320 pounds. That means 320 pounds or less, right? So 320 is the maximum. So it includes this section here, and that section. It includes really everything from 320 back to the left, the smaller numbers. Well, how many sections does that make up? Well, here's one, here's a second one, and then here's a third one, right? So 3 sections, each one is 25%. 25 times 3 is 75%. So 75% weigh no more than 320 pounds. Okay? Okay, moving on. Estimate. So given some information about a survey or about some data, can we estimate for a whole population? And yes, we can certainly do that. So let's look at example 1. A random survey was conducted about students' favorite vegetables. 10 students voted for green beans, 12 students voted for corn, and 3 students voted for broccoli. If there are 600 students in the school, estimate the number that prefer corn. Okay, so that's what we're focusing on. Estimate the number that prefer corn. Okay, there are 2 ways that we can do this. The first way is that we can set up a proportion. So use a proportion. And we did proportions way back in first semester, before Christmas time. So proportions are 2 fractions set equal to each other that we can solve by cross multiplying. Okay, 2 fractions set equal to each other that we can solve by cross multiplying. So let's first find some important information. Okay, so how many students participated in this survey? Well, we aren't told that, but we do know that 10 students voted for green beans, 12 students voted for corn, and 3 students voted for broccoli. Well, what is 10 plus 12 plus 3? So 10 plus 12 plus 3. If I add that all up together, I get 25. So 25 students were surveyed. Okay, now how many said that they like corn? 12 students voted for corn. So 12 out of 25, right? Well, how do I write that as a fraction? 12 over 25. Okay, and I want to set that equal to another fraction. Now, we know we're going to put 600 in there because we know that there are 600 students in the school, and that's our population. But where does it go? Well, when we think about this, the whole number of students that participated in the survey was 25, and only part of them said that they liked corn. So is 600 the whole or the part? Does it go on top where the part goes, or does it go on the bottom where the whole goes? If you said it goes on the bottom where the whole goes, you're correct. I'm going to put 600 right here. Now we're trying to find the part of the population that likes corn. So we don't know that value. So I'm going to use a variable, and I'm going to use x just because it's common. So we have 12 over 25 equals x over 600. So to solve this, I'm going to cross multiply. So I'm going to multiply 25 times x, which is simply 25x. And I'm going to set that equal to 12 times 600. And when I put that into my calculator, I get 7,200. Now to get x by itself, I divide by 25 on both sides. So 7,200 divided by 25 is 288. So x equals 288 students. So out of the whole population of 600 students, we can estimate that 288 of them would prefer corn. Now, we can also do this another way. And I just want to show you that second way because you might prefer that way. So the second option is we could use percentages. So use percentage to estimate. So using a percentage is a little bit different. Okay, we're still focused on 12 students out of 25 that were surveyed. So I'm going to start with that same fraction, 12 out of 25, or 12 over 25. Now, what operation do fractions represent? If you said that they represent division, you're correct. So if I put in my calculator 12 divided by 25, I get 0.48, which really means 48%. Okay? So I'm now going to use this right here, I'm going to bring it down. So I'm going to say 0.48 times the total number of the population, 600 students. And when I multiply that together, I should get the same answer. So put that in your calculator, 0.48 times 600. And in fact, you do get 288. 288 what? 288 students prefer corn. Okay, so it's just another way that we can solve these estimation problems. Let's look at another example. Mountain View Middle School randomly surveys students about how much time they spend on homework each night. They find that 30 out of 96 students spend less than 30 minutes on homework each night. If there are 400 students in the school, about how many students spend less than 30 minutes on homework each night? Okay, some important information. They found that 30 out of 96 students spend less than 30 minutes on homework. So that right there is my survey results, right? And then we know that there are 400 students in the school. So that right there is my population. Okay, so let's use method A first. Use a proportion. So use a proportion. Remember, proportions are two fractions set equal to each other, and then we solve them by using cross multiplication. So I'm going to have two fractions set equal to each other. Okay, let's talk about my first fraction. My first fraction comes from my survey results. So 30 out of 96. Well, 96 is the whole group, and 30 is the part that said that they did homework for less than 30 minutes. Okay, now I want to set that equal to another fraction. So I know I'm going to put 400 in this fraction. But does 400 go in the part section or down here in the whole section? Well, 400 is the whole population, so it goes on the bottom with the whole. And we're trying to find the part. So I put an X or any other variable there. And now I want to cross multiply. So 96 times X is simply 96X. And now I multiply 30 times 400. And 30 times 400 is 12,000. Now to get X by itself, all I have to do is divide by 96 on both sides. Okay, so 12,000 divided by 96 is 125. So X equals 125 students. So we can estimate that 125 students out of 400 spend less than 30 minutes on homework each night. Now let's also look at using our second method here, using a percentage. Okay, so use a percentage. Okay, remember, when we use a percentage, we start with our survey results. So our survey results were still 30 out of 96. So I'm going to write that as a fraction. So 30 out of 96. Now fractions represent division. So in my calculator, 30 divided by 96 is 0.3125. And it's important that I don't round anything here. I need to keep it as is. And just so you know, this represents 31.25%. Because remember, to find the percent, we move that decimal once, twice over, so it would go right in between that 1 and that 2. Okay, so now that I know the percent, I'm going to keep the percent in decimal form, and I'm going to bring it down here, and I'm going to multiply it. So 0.3125. I'm going to multiply it with my whole population, which was 400 times 400. So 0.31 times 3125, times 400. When I put that in my calculator, I get 125. 125 what? 125 students. So that is the end of our little mini lesson from lesson 6-2. Y'all have a great day.